Okay, guys, round two. Here we go. We are on page 4 of our packet. So, let's get back at it. According to a recent survey, 20 out of 25 students do not walk to school. What is the ratio of walkers to total students? Well, if 20 kids do not walk out of 25, how many do walk? Well, 5 out of 25. Okay? Always read your directions because it does make a huge world of difference. All right? I promise you on a multiple choice test, the answer 20 out of 25 would be there. This, of course, reduces the 1 over 5 or 1 to 5. The answer 4 to 5 would also be there, but again, read directions. 20, cross multiply. 3x equals 7 times the quantity x minus 4. Okay? 3x equals 7x minus 28. Subtract 3x over. 4x minus 28. Add 28 over. Divide. X equals 7. Okay? Again, make sure you distribute because I promise you'll see one like that. Mr. Jones and Me, that's a good song, look it up, has taken a survey of college students and found that 1 out of 3 students are liberal art majors, 1 over 3. If a college has 12,000 students, what's the number of students who are liberal art majors? So, x over 12,000. Cross multiply. 3x equals 12,000. X equals 4,000 students. Okay? Again, liberal art majors on top, total. Liberal art majors on top, total. Okay, very good. A worker in an assembly line takes 6 hours to produce 27 parts. So 6 hours, 27 parts. At this rate, how many parts can she produce in 18 hours? Well, 18 hours over x parts. Cross multiply. We get 6x equals 18 times 27. So off the top of my head, I do not know. 486. Divide both of them by 6. We get x equals 81 parts. Which should make sense because the more hours you have, the more parts you can create. Number 23. Are the two polygons similar if they are not drawn to scale but assume all angles are 90 degrees? If not, explain why. If all the angles are 90 degrees, then we're looking good already. We're next looking at all of our sides. So 1 over 4 is 1 over 4. 8 over 32. Write these out for you guys. 1 over 4, 8 over 32, 5 over 20, 4 over 16. If I reduce all of them down, I get 1/4 for all of them. So yes, they are similar. Okay. Again, the ratio has to be there. It's a 4, by the way. Sorry, it's terrible. All right, 24 and 25. If you guys are intently listening to this right now, I will let you guys in a little secret. These are exact same questions. 24 and 25 are on your final. You're welcome, okay? As long as you're listening to this, you are definitely getting at least 2 questions right. If 2 polygons are similar, then the corresponding angles must be congruent, okay? Okay, they must be congruent. That's for the angles. Now, if 2 polygons are similar, then the corresponding sides must be proportional, okay, or the same ratio. So again, if you guys are listening right now, okay, you definitely got 2 questions right. First one's congruent, second one's proportional, okay? Wonderful. 26. If triangle ABC and triangle XYZ are similar with angle A equal to angle X, let's just go ahead and draw this out because it's definitely going to help us. So A and X, B and Y. If AB and BC, so here's AB is 6 inches, BC is 6 inches, and AC is 6, 13, 15, my bad. And XY is 13, find XZ, which is over here. Okay, so if we have the same thing taking place here, they're similar, we know we have to set up a ratio. So what I can do is 6 over 13 equals 15 over, call it X. Okay? You're always comparing sides. Draw out your picture. It's going to help you immensely. So 6X equals 15 times 13. Okay, 195. 195 divided by 6, 32.5. Perfect. Okay? Very good. Alrighty, moving on to page 5. Pardon me. Given that triangle ABC is similar to triangle DEF, solve for x and y. Alright, again, our setup ratio, 6 over 4 equals 10 over x. Okay, I can cross multiply this, 6x equals 40. 40 divided by 6. It's kind of hard to see that, 6.66. Okay, good. And then for my y, I'm looking at y over 6 equals 6 over 4. You always want to use your constant here, like the 6 over 4, like there's no decimals, so I stick to whole numbers as opposed to decimals. 4y equals 36, y equals 9. Okay, good. The perimeter of triangle PQR is 45. PQ, let's see here real quick. PQR, PQ is 15. And then over here we have triangle STU, and they're saying ST is 10. What's the perimeter of STU? Well, here's the deal. The perimeter over here is, what do we say, 45 units? The perimeter follows the same with the ratio of the size. So 15 over 10, all right, is a 3-to-2 ratio. So what that means is, if I multiply, oops, I want to do the reverse here, so I want 2/3 of it. I want 2/3 of 45 to find the perimeter over here. Okay, so I'm going to do 2/3 times 45. 45 divided by 3 is 15, times 2 is 30 units. Okay, which makes sense also because if this is a larger side, then it has to be bigger. There you go. But the ratio of the sides follows for the ratio of the perimeters as well. Which triangle is not similar to any of the others? Okay, better hope you get one like this because it's really simple. 60 degrees, cool, and 90, awesome. That means that has to be 30. 30 degrees and 90, sweet, that's got to be 60. 60 and 30 mean the other angle has to be 90. Meanwhile, over here, 50 and 80 degrees, different. Okay, does not work. 2 ladders leaning against the wall. This angle is shown. How long is the shorter ladder? So we're going to call this x. Again, I'm comparing sides. 72 over x equals 60 over 20. Make my life easier, I can reduce this down to 3 over 1. So 3x equals 72 when I cross multiply. Oops. X equals 24 feet. All right. Wonderful. Down to the 6th page, or we're done with the 5th page, on to the 6th. Given PQ is parallel to BC, right, which again are these little arrows to show that they're parallel, find AP. Well, I can say x over 6 equals 6 over 9. Boom, 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 boom. Okay? When I cross multiply this, 9x equals 36. X equals 4. Awesome. We can say units, or if there's feet or inches, whatever it may be. Okay, so setting up your ratio there. Find the length of the leg of this right triangle, given approximation to 3 decimal places. Good old Pythagorean theorem. A, B, C. A squared plus 15 squared equals 17 squared. So A squared plus 225 equals 289. Okay, let me just double check my math here. I don't want to give you guys the wrong thing. I know you guys are good at catching me when I'm wrong. Oops, sorry. 17 squared. 289, cool. Subtract 225 from 289, we get 64. Oh, you're not even able to see the calculator, my apologies. Right there. So A squared equals 64. Please don't forget the opposite of squaring something is to square root it. So A equals 8. Here we go. Okay, very good. The sum of the measures of the interior angles of a convex quadrilateral is, okay, quadrilateral, we got this formula, n minus 2 divided by, n minus 2 times 180 gives you how many the total angles have to add up to. Well, a quadrilateral has 4 sides. So if I do 4 minus 2 times 180, I get 2 times 180, or 360 degrees. Okay? Much the same for the next one. The measure of each interior angle of a regular hexagon is what? Well, I have to know what the 6 angles of a hexagon add up to first. I'm going to use the same equation. 6 minus 2 times 180. 4 times 180, we're looking at 720 degrees. That's not my answer, though. They want to know what each interior angle has to be. So I'm going to take this 720 and divide it by how many total angles I have in here, which is 6. So 120 degrees each. Okay? Excellent. Now, 35, the measure of each exterior angle of a regular octagon is what? All the exterior angles for any polygon have to add up to 360 degrees. Okay, it's much like a circle when we're going all the way around. So the only thing you have to do here for anything with exterior angles is count how many total angles are on the inside. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to take 360 and divide it by 8. And I'm left with 40 degrees. Okay? Oops, sorry. I'm getting way ahead of myself. 360 divided by 8. 45. Okay? 45 degrees. Very good. Okay. Let's see here. Last one for right now, I would say. This is our 5th page. Oh, this is our 6th page. Good. A park has a circular swimming pool. The diameter of the pool is 25 meters. What's the distance traveled if you swim around the edge of the pool once? All right, so if I'm swimming around the pool, just the outside, that's your circumference, which is 2 pi r. Please be careful and don't fall into a trap. They're giving us the diameter here. So it's not going to be 25, but 12.5. Okay? Now it's telling you to use 3.14 here. So I'm doing 2 times 3.14 times 12.5 to give me 78.5 meters. Okay? And this is just a distance. It's not an area, so it's just 78.5 meters, not squared. Alrighty? Okay, we have our 2nd video down. We have 6 pages down out of 11. Expect 2 more videos. Okay? Again, keep up the good work. Hang in there. The end is almost here. Anything I can do to help you, please don't hesitate to ask. But as always, good luck. We're all counting on you.